Hey, thanks for clicking on my video. If this video helps you, please consider liking this video and subscribing to my channel. It is greatly appreciated and it really helps. Let's get to the video. All right, from the previous video, now we know how to evaluate recursive rules for sequences. Well, now how can we write a recursive rule for a sequence? Well, we're going to focus on two main types of sequences here in this video, with a couple extra sequences that don't actually fit in these two categories, but they still are a sequence, and we're going to see how we can write a recursive rule for them. So first of all, we have an arithmetic sequence, and that is a sub 1 equals a number. So what I mean by that is the first number of the sequence has to be given to you. And then from there, we're going to write a sub n is equal to a sub n minus 1 plus the common difference. So just remember that this right here, a sub n minus 1, that is referring to the previous term. And then d represents the common difference, right? Or what are we adding to get to each term? All right, and then for geometric, once again, we need to have that first term, and then a sub n equals r times a sub n minus 1. So once again, this is previous term, but now r is our common ratio, because for geometric sequences, we are multiplying to increase our sequence. All right, so let's look at a couple examples here. Number 1, we have negative 11, negative 6, negative 1, 4, and 9. So we look at that, we're trying to establish a pattern here. It looks like we are adding 5, right? So plus 5, plus 5, plus 5, and plus 5. So that tells me that this is an arithmetic sequence. So now I can use this rule up here to write our recursive rule. So we need to list our first term. So a sub 1 equals negative 11, comma, and then a sub n equals a sub n minus 1, and then plus our common difference. So what are we doing to get to the next term? Well, we are adding 5. So that would be our recursive equation for number 1. All right, number 2, we have 24, 12, 6, 3, and 3 halves. So very quickly there, we can see we are decreasing, and it looks like we're decreasing pretty quickly. So let's think more about geometric rather than arithmetic. What are we multiplying by? Well, you might say, we're not multiplying by anything. We're dividing by 2. Yes, you're correct, but we always want to reference our common ratio by what we're multiplying by. So if we're dividing by 2, what are we multiplying by? We're multiplying by 1/2. So that's what we're doing here. Multiply by 1/2 times 1/2 times 1/2 times 1/2. So now we recognize that it's geometric, so now we can use this recursive rule. So let's list our first term, which would be 24, and now we can write a sub n equals, our common ratio was 1/2, and then times a sub n minus 1. And that'd be our recursive rule for example number 2. All right, well, if you notice on these last two examples, they are not going to be arithmetic or geometric. However, they are still a sequence, and so since it's a sequence, we can write a recursive rule for it. We just have to establish the pattern. So for number 3, we have 2, 4, 16, 256, 65,536, so on and so forth. So hopefully you're noticing that something is being squared here. So my first term is 2, my second term is 4, right? So if I take 2 and I square it, we get 4. 4 squared would be 16, 16 squared would be 256, so on and so forth. So we need to list our first term, so a sub 1 equals 2. But now we're going to say a sub n is equal to a sub n minus 1, the previous term squared, right? So if I think, for example, my third term is 16, right? So I'd plug in a sub 3 minus 1, so we would do a sub 2 squared. Well, a sub 2 is my second term. My second term is 4. 4 squared is 16. Okay, so that's how we could write our rule, recursive rule for number 3. All right, number 4, we have 5, 6, 11, 17, 28. So for this one, once again, neither arithmetic nor geometric. But if we notice that we are adding 5 plus 6 gives me 11. 6 plus 11 gives me 17. 11 plus 17 gives me 28, so on and so forth. So we're actually adding the two previous terms together to get the next term. So in this case, how many terms do you think we're going to need in our sequence to know or to be able to extend the pattern? Well, we're going to need 2, right? We're going to need the first 2, because to find the third term, I have to add the first 2 terms together. Well, there's no way I can figure out what the third term is if I don't know the first and the second term. So now when we write a sub 1 equals 5, we need to also write a sub 2 equals 6. And now we can write a sub n is equal to. All right, so now if I take 11, what two numbers did I multiply together to get 11, or not multiply, add? That was 5 and 6, right? Well, 5 plus 6, 5 is my first term, and 6 is my second term. So in relation to 11, which is the third term, it would be the first term plus the second term. Well, I'm going to write this as a sub n minus 2 plus a sub n minus 1. So now let me explain that a little bit. Once again, 11 is my third term. That would be a sub 3, right? A sub 3 is equal to 11. Let's actually move this down here. So a sub 3 is equal to 11, right? And so to find that, I would need to do a sub 3 minus 2 plus a sub 3 minus 1. So this is going to be a sub 1 plus a sub 2, right? And so that's my first term plus my second term. Okay, so 2 examples of arithmetic, geometric, and then a couple examples of neither arithmetic nor geometric, but still a sequence that we can write a recursive rule for. Hope that helped.